Okay, so now I'm going to look at part D. Now I know that these are the most confusing questions, and these ones involve SUVAT. That's why we did SUVAT first, because it's so important, yeah? So let's read. I've just cut out parts A, B, and C, and I've just got the text from the original question and then part D. So let's read part D really carefully, and then we'll discuss, before we even try and work out what's going on, we'll discuss what's happening. After descending for 1.2 seconds, particle A reaches the plane. So this is coming down for 1.2 seconds and then it reaches the plane. Okay. That means that this is going to be ascending for 1.2 seconds as well, isn't it, before something happens. It is immediately brought to rest by the impact of the plane. The initial distance between B, this one, and the pulley, okay, so that's the pulley, is such that in the subsequent motion, B does not reach the pulley. Okay, so I don't need to worry about that crashing into that. Find the greatest height reached by B above the plane. Now, this question would not be possible were it not for something that was said in the text earlier. So the particles are connected by a light and extensible string which passes over a fixed pulley. The system is held at rest with the string taut. The hanging parts of the string vertical, this bit here, the same height above a horizontal plane. So this height here, let's use our nice arrow. I know that this height here is exactly the same as this height here. Now I'm going to discuss what's going to happen. Let me just put in my acceleration. I know it's accelerating down still, isn't it? Nothing has changed. I know that it's going to be moving down at a quarter G, just as A will be accelerating up at a quarter G. Right. So when I tried to do this initially, I was like, well, this is impossible because I don't know what the height is, this initial height. But if I think about it, the height that this drops, yeah, so whatever height this drops is the initial height above this, yeah? So it's gonna, whatever A drops is the initial height of B, but then at the same time, if you think about it, B will have also moved that height. So if I think about it, how to explain this well, it's very difficult to get your head involved in what's going on. I just Googled if I could find like a pulley I could manipulate, which I can't, unfortunately. So this is going to move down. Whatever height that moves down, that's the initial height of B, because they're at the same height above the ground. But if that's moved down by that, that will in fact be two lots of that, yeah? Then the last bit is the tricky bit, which we have discussed before. So that will be the initial height, whatever that is, then it will move up that height again, and then it will act freely under gravity. So the momentum of that particle will mean that it moves freely under gravity, and the greatest height that reaches will be the greatest height reached by B above the plane. Okay, right. So I'm going to write that down so you've got it nice and clearly. I'll use the text bit here, yeah? So because because the height is the same above the plane, the distance A falls is the initial height of B above the plane. Right. Okay, so I know that the height, because the height is the same above the plane for both part A and B, particle A and B, the distance A falls is the initial height of B above the plane. Okay, well, so the first thing I'm going to think about is I'm going to look at A. I'm going to resolve for A. And I'm going to list my SUVAT. It's involving distance now. So if I think about it, if I'm using my F equals ma, that's not going to help me. It might help me if I needed A in my SUVAT equation, but because I'm already given the acceleration for this bit, which is a quarter G, I don't need to. So for A, I'm going to resolve for A. I'm going to call down positive because that's the direction that it is accelerating. So let's list our SUVAT. The distance is the thing that I want. It tells us in the question the system is held at rest. Therefore, I know that the initial velocity is 0. The final velocity I don't know, but we'll come on to that in a second. I'm going to want that. My acceleration downwards is 1/4 g. And luckily in my question, they told us that it descended for 1.2 seconds. So let's think about what we have and what we want. We want S, and we have the initial velocity, we have A, and we have T. Let's think about our Suvat equations. The one that I want is S equals ut plus 1/2 at squared. Then I've got S equals, well, my initial velocity was 0. That makes it a bit easier. So I've just got 1/2. I know it's accelerating downwards at 1/4 g times T, which I'm told in the question is 1.2 squared. Right, so if I plug that all in, I get S equals 1.764. So let's think about again what's happening. This has gone down by 1.764. So that's therefore the initial height, but because it's moved up, as A moves down, B moves up, so far it's going to move, well, it's this far above the ground, and then it's going to move a further 1.764. Okay. Then what's going to happen is it's going to move freely under gravity. B is going to move freely under gravity. Right. So I'm now going to look at B when it moves freely under gravity. And I know, let's use that same font size. So now I'm going to look at looking at B as it moves freely under gravity. And I know that the final speed of A, as A hits the ground, will be the initial speed of B just before it moves freely under gravity. So the final speed of A is initial speed of B. So let's still look at this then. So I've still got, so I'll just list my Suvat again. So my Suvat was, so I'm still looking at A because I need that final speed. Sorry. So it's just the same Suvat as before, the exact same scenario. I've actually worked out now that my distance that it moves is 1.764. My initial speed, because it's released from rest, is 0. My final velocity I don't know, but I now want. I know that it's descending, and I said that down is positive. It's descending at 1/4 g. And I know my time is 1.2. So I could use pretty much any equation I want. I'll probably stay clear of S if I'm honest, just in case I made a mistake on S and I'd like to get some accuracy marks. So now I'll use U, V, A and T. So if I use V equals U plus AT, plug in what I've got, and V is already the subject of that anyway. So V equals U, which I don't which is 0, makes my life easier. And I know that therefore the final velocity is just going to be 1/4 g, because that was the acceleration, times time, which is 1.2. So V is actually equal to 2.94 meters per second. Right, so B was 1.764 above the ground. When A moved down that much, B therefore moved up another 1.764. Then that it's going to move freely under gravity here. So it's going to go up and then come down. So for the final bit, so this was part 1. This is part 2. And then let's call this bit part 3 here. So let's just call that part 1. This bit part 2, and this is going to be part 3. Here we go. So now I'm going to look to do suvat for B. So I'm going to look at B. So for B, I'm going to list my suvat. So I don't know what the distance up is, and that is what I want. I know that the initial velocity of B will be the final velocity with which A hits the ground, which I worked out before, which is going to be 2.94. Now, this is the bit we've discussed quite a few times. At its maximum height, if you think about it, just before it starts to descend again, my initial velocity, my final velocity will be 0. Because there's no tension in the string, the acceleration is actually going to be gravity, or it's going to be decelerating at gravity. So I've got minus 9.8, and t I don't know. Let's think about the equations that I want. Well, I want, so I'm going to have to do this down here. What do I have and what do I want? S, U, V, and A, nothing to do with t. Therefore, the equation I want is v squared equals u squared plus 2as. Plug in what I've got. Well, my final velocity was 0 equals u squared, which was 2.94 squared plus 2 lots of minus 9.8. Because remember, and I should have put that on there, I'm going to call up positive this time. Minus 9.8, 2 times minus 9.8, and then that will be S. So if I rearrange to make S the subject, you should have got S equals 0.441. So let's call that part 3. Let's think about what's happened now. So I know that initially it was 1.764 above the ground. As A moved down 1.764, it moved a further 1.764 up. And then finally it was the distance it moved up when it was acting freely under gravity. So that momentum, remember, it will go up and then it will move freely under gravity once the tension's gone in the string. So we had 1.764 was the initial height above the ground. It moved up a further 1.764 as A descended, and then the point at which it moved freely under gravity was 0.441. Sum all those together and we get 3.969 meters, which I advise that you leave the 3 significant figures, would be 4.00 meters. So that's the final step. Sorry, that's quite a long video, but inevitably it was going to be because it was worth 7 marks. Okay, please email me with any questions that you have. This is really important that we have this down because I'm going to be setting more of these for tomorrow. Okay, please email me with questions and I can give you a ring if we need to. All right, see you later, guys. Bye.